Welcome to Yashil Chemistry Academy for CBSE 12 Chemistry. Today, we will see the lesson solution. Concentration of solution, we will take it up today. We will see various ways of representing the concentration of solution. And then we will also do some numerical based on concentration of solution. Right. Solution is a homogeneous mixture of two or more substances. Concentration of solution can be represented in many ways. We will see some ways of representing concentration of solution. One is mass percentage. It is the amount of solute present in 100 gram solution. Mass percentage is equal to mass of solute divided by mass of solution into 100. If we say 10% by mass of aqueous solution of sodium hydroxide, 100 gram solution contains 10 grams of sodium hydroxide solute and 90 grams of water solvent. Volume percentage. It is generally used when two liquids combine together to give you a solution. Example, 5% by volume of aqueous solution of ethanol. Volume percentage is equal to volume of solute divided by volume of solution into 100. 5% by volume of aqueous solution of ethanol. In 100 centimeter cube solution, 5 centimeter cube is ethanol, which is a solute, and 95 centimeter cube is water, which is a solvent. Then mole fraction. It is the number of moles of component divided by total number of moles in this solution. For example, I want to find out the mole fraction of 4 grams of sodium hydroxide dissolved in 972 grams of water. First, find out the number of moles of solute and solvent. Number of moles of solute sodium hydroxide, mass of sodium hydroxide divided by molecular mass of sodium hydroxide. 4 by 40, 0.10. Same way, number of moles of solvent, water, mass of water divided by molecular mass of water. 72 by 18, 4 here. So total number of moles is 4 plus 0.10, 4.1 here. Mole fraction of NaOH, number of moles of NaOH divided by total number of moles. 0.1 by 4.1, 0.024. Mole fraction of water, number of moles of water is 4 divided by total number of moles 4.1. 4 by 4.1, 0.976. Always, if you add all mole fraction, it will become equal to 1. Part per million. It is normally used when a gas is dissolved in a solvent to give a solution because solubility of a gas in a solvent is very less here. It is the amount of solute present in 10 power 6 gram solution. Seawater contains 5.8 part per million oxygen. That means if I take 10 power 6 gram solution of seawater, it will have 5.8 gram of oxygen. Molarity and molality are commonly used terms here. Molarity is the number of moles of solute present in 1 liter of solution or 1 decimeter cube solution. Molarity is equal to number of moles of solute divided by volume of solution in liters or decimeter cube. For example, 4 grams of sodium hydroxide dissolved in 200 ml solution. Number of moles of NaOH, mass of NaOH divided by molecular mass of NaOH, 4 by 40, 0.10 moles. Volume of solution in decimeter cube or liters, 200 centimeter cube divided by 1000, 0.20 decimeter cube. So molarity is equal to number of moles of methanol divided by volume of methanol in, number of moles of sodium hydroxide divided by volume of sodium hydroxide in decimeter cube. So 0.10 divided by 0.20. That is 0.50 mole per decimeter cube. Molarity equal to mass of solute divided by molar mass of solute into 1000 by volume of solution in centimeter cube. So 4 by 40 into 1000 by 200. That is 0.50 mole per decimeter cube. If percentage mass is given, percentage mass of solute divided by molar mass of solute into 10 into density. Example, molarity of 49% by mass of sulfuric acid having a density of 1.5 gram per centimeter cube. So 49 divided by 98 into 10 into 1.5, which is 7.5 mole per decimeter cube. Molality, it is the number of moles of solute in 1 kilogram of solvent. Number of moles of solute divided by mass of solvent in kilogram. Example, 4 grams of NaOH dissolved in 100 grams of water. Number of moles of NaOH, 4 by 40, 0.10 moles. Mass of water 100 by 1000, 0.10. So molality equal to number of moles of NaOH divided by mass of water, 0 in kilogram, 0.10 by 0.10, 1 mole per kilogram. Formula: mass of solute divided by molecular mass of solute into 1000 by mass of solvent, or percentage mass of solute divided by molecular mass of solute into 1000 by 100 minus percentage mass of solute. Example: concentrated sulfuric acid is 49% by mass. Determine its molality if the density of the solution is 1.5 gram per centimeter cube. So percentage mass of solute is 49 divided by molecular mass of solute 98 into 1000 divided by 100 minus 49. That is 49 by 98 into 1000 by 51, 9.80 mole per kilogram. Effect of temperature and concentration of solution. In a closed system, when the temperature is increased, mass does not change, but the volume of solution will expand here. Molality is number of moles of solute divided by mass of solvent in kilogram. So all mass terms are involved here. So molality does not change with the temperature. Whereas molarity, number of moles of solute divided by volume of solution in decimeter cube. Here, when you increase the temperature, volume will expand. Therefore, molarity of the solution will decrease as the increases in temperature is noticed. Solubility is the amount of solute that can be dissolved in a given amount of solvent at a particular temperature. Solid dissolves in a liquid to give a solution. Most of the process where solid dissolved in a liquid to give a solution is in the endothermic process. Delta H is greater than 0. That is, heat is absorbed by the system from the surrounding. Solubility increases when the temperature is increased. Therefore, solubility of a substance will increase as the temperature increases. In some cases, dissolution of solid in a liquid to give a solution is an exothermic process. In such cases, solubility will decrease when the temperature is increased. Pressure has no effect on the solubility of solid in a liquid to give a solution. Now let us see the formula for finding out the concentration of solution, and we will do some numerical based on it. Percentage mass of solute. Mass of solute divided by mass of solution into 100. Percentage volume of solute. Volume of solute divided by volume of solution into 100. Part per million, mass of solute divided by mass of solution into 10 power 6. Mole fraction of solute in a solution containing solute and solvent. Number of moles of solute divided by number of moles of solute plus number of moles of solvent. Mole fraction of solvent, number of moles of solvent divided by number of moles of solute plus number of moles of solvent. Always total mole fraction is equal to 1. Molarity, number of moles of solute divided by volume of solution in decimeter cube per liter. Or mass of solute divided by molecular mass of solute into 1000 by volume of solution in centimeter cube. Or molarity is equal to percentage mass of solute divided by molecular mass of solute into 10 into density of solution. 1 liter equal to 1 decimeter cube, which is equal to 1000 centimeter cube. Molality, number of moles of solute divided by mass of solvent in kilogram. Or I can write it as mass of solute divided by molecular mass of solute into 1000 by mass of solvent in gram. 1 kilogram equal to 1000 gram. In terms of percentage mass of solute divided by molecular mass of solute into 1000 divided by 100 minus percentage mass of solute. We'll do few numerical based on this. First one is based on percentage mass and part per million. A sample of drinking water contains 15 part per million chloroform, CHCl3 by mass. Express this in percentage mass. What is given is 15 part per million. That is, if I take 10 power 6 gram solution, 15 grams of chloroform is present. What is asked here is finding out the percentage mass. That is, how much of chloroform present in 100 gram solution. So I can write it as 10 power 6 gram solution contains 15 gram chloroform. 100 gram solution contains how much of chloroform? 15 into 100 by 10 power 6. 15 into 10 power minus 4 here. That is percentage mass of chloroform here. The next part of the question is find out the molality of the solution. Now percentage mass is known, molecular mass is known. So I can go for the formula. Molality equal to percentage mass by molecular mass into 1000 by 100 minus percentage mass. So 15 into 10 power minus 4 into 1000 by divided by 119.5 into 100 minus 15 into 10 power minus 4. 100 minus 15 into 10 power minus 4, I can take it as 100. So 15 into 10 power minus 4 by 119.5 into 1000 by 100, which is 1.256 into 10 power minus 4 mole per kilogram. Whenever you do the numerical, write the formula clearly, show the substitution clearly, write the answer with its unit. Unit also carry mass. Concentrated sulfuric acid is 49% by mass. Density of the solution is 1.5 gram per centimeter cube. Determine its molality and mole fraction of sulfuric acid in the solution. Molecular mass of sulfuric acid 98. Sometimes molecular mass will not be given to you in the exam because atomic mass of hydrogen, sulfur and oxygen is known to you. First method using the formula. Percentage mass of solute divided by molecular mass of solute into 10 into density. So 49 by 98 into 1.5 into 10, that is 7.5 mole per liter. Molality, percentage mass of solute by molecular mass of solute into 1000 divided by 100 minus percentage mass of solute. So 49 by 98 into 1000 divided by 100 minus 49. So it is equal to 9.80 mole per kilogram. Second method is from concepts here. 100 gram solution contain 49 grams sulfuric acid, 51 gram water. That is the meaning of 49% by mass of sulfuric acid. So molarity, mass of solute by molecular mass of solute into 1000 by volume of solution. That is the volume occupied by 100 gram solution. So 100 by 1.5. Density is 1.5. That gives the volume of solution. Now substitute here. So 49 by 98 into 1000 by 100 by 1.5. That is equal 49 by 98 into 1000 into 1.5 by 100, which is equal to 7.5 mole per liter. Molality, mass of solute by molecular mass of solute into 1000 by mass of solvent. 49 by 98 into 1000 by 51, 9.80 mole per kilogram here. Mole fraction, number of moles of sulfuric acid divided by number of moles of sulfuric acid plus number of moles of water. Number of moles of sulfuric acid is 49 by 98. 49 grams of sulfuric acid. Molecular mass is 98.50. Number of moles of water 51 divided by 18. 51 grams of water divided by molar mass of water is 18. 2.83. Total number of moles is 3.33. So mole fraction of sulfuric acid. Number of moles of sulfuric acid divided by total number of moles. 0.50 by 3.33. 0.150. Mole fraction of water is 1 minus mole fraction of sulfuric acid. 1 minus 0.150, 0.850. Concentrated nitric acid is 68% by mass. Density of the solution 1.5 gram per centimeter cube. Calculate the volume occupied by 20 gram of nitric acid. I'll be using two formulas here. Number one, percentage mass by molecular mass into 10 into density. Number two, I'll be using the formula mass of solute divided by molecular mass of solute into 1000 by volume of solution. Same solution, so molarity is same here. I can equate the two equations and find out the volume occupied by 20 grams of nitric acid. Percentage mass by molecular mass in 10 into density, 68 by 63 into 10 into 1.5. That is the in terms of percentage mass. Then in terms of mass by molecular mass in 1000 by volume, that is 20 by 63 into 1000 by volume. So I can write 68 by 63 into 10 into 1.5 is equal to 20 by 63 into 1000 by volume of solution. So by using this equation, I can find out volume of solution is equal to 19.61 centimeter cube. Another method is from the concept here. See, I want to first find out what is the volume occupied by the 100 gram solution. 1.5 gram solution occupy a volume of 1 centimeter cube. That is the density given here. 100 gram solution occupy 100 by 1.5 centimeter cube. This is occupied by 68% nitric acid. That is 68 gram nitric acid. 68 gram nitric acid occupies a volume of 100 by 1.5 centimeter cube. 20 gram of nitric acid, what is the volume occupied? 100 by 1.5 into 20 by 68, which is 19.61 centimeter cube. Right. Now, one textbook numerical. Sodium carbonate and sodium bicarbonate mixture containing 1 gram is completely neutralized by 0.1 molar HCl. Determine the volume of HCl needed if the mixture contains equimolar mixture of sodium carbonate and sodium bicarbonate. Molecular mass of sodium carbonate 106 gram per mole, sodium bicarbonate 84 gram per mole. So first you have to use the expression given here, equimolar mixture. That is same number of moles of sodium carbonate and sodium bicarbonate. That is the key word here. Mass of sodium carbonate x gram, mass of sodium bicarbonate 1 minus x gram. Number of moles of sodium carbonate, mass by molecular mass, x by 106. Number of moles of sodium bicarbonate, 1 minus x by 84. Number of moles are same, So I can write it as x by 106 equal to 1 minus 6 by 84. Using this equation, I can find out x here. X equal to 106 by 190, which is the mass of sodium carbonate. Number of moles of sodium carbonate, mass by molecular mass. So 106 by 190 into 1 by 106, which is 1 by 190 moles. So I know the number of moles of sodium carbonate is equal to the number of moles of sodium bicarbonate, which is equal to 1 by 190 moles. Second part, I want to find out how much of HCl is required by using the equations. Sodium carbonate plus 2 HCl. Na2CO3 plus 2 HCl gives 2 NaCl plus H2O plus CO2. 1:2 ratio. 1 mole of sodium carbonate requires 2 moles of HCl. 1 by 190 moles of sodium carbonate will require 2 times 2 by 190 moles of HCl. Other one is bicarbonate. NaHCO3 plus HCl gives NaCl plus H2O plus CO2. 1:1 ratio. 1 mole of sodium bicarbonate requires 1 mole of HCl. 1 by 190 moles of sodium bicarbonate requires same amount, 1 by 190 moles of HCl. Total number of moles of HCl is 1 by 190 plus 2 by 190, 3 by 190 moles here. Molarity equal to number of moles of HCl divided by volume of solution in decimeter cube. Now I know the number of moles of HCl, I know the molarity, so I can find out the volume of solution, right? 0.10 equal to 3 by 190 into 1 by volume of solution. So volume of HCl is equal to 3 by 190 into 1 by 0.10, which is 0.1578 decimeter cube or 157.8 centimeter cube. Now you see, finding out the molality from molarity here. Calculate the molality of 1 molar solution of NaNO3. Density of solution 1.25 gram per centimeter cube. Molar mass of NaNO3 is 85. First method using the formula. Molarity equal to percentage mass by molecular mass into 10 into density. Molecular mass is known to me, density is known to me. Molarity is given 1 molar. So I find out the percentage mass of solute. 1 is equal to percentage mass of solute by 85 into 10 into 1.25. Percentage mass I calculate, it is 6.8%. Then molality equal to percentage mass by molecular mass into 1000 by 100 minus percentage mass. So 6.8 by 85 into 1000 by 100 minus 6.8, 0.858 mole per kilogram. This is one method. Another method is from the concept here. When I say 1 molar NaNO3, it means 1 mole of sodium nitrate in 1000 centimeter of solution, or 85 gram of sodium nitrate in 1000 centimeter of solution. Find out the mass of 1000 centimeter of solution. Density is given as 1.25 gram per centimeter. So 1.25 into 1000 is 1250 grams. Mass of solvent is mass of solution minus mass of solute. So 1250 minus 85, 1165 grams. So I find out the molality, mass of solute by molecular mass of solute into 1000 by mass of solvent, which is 85 by 85 into 1000 by 1165, which is equal to 0.858 mole per kilogram. Next one is from the molality to molarity. Calculate the number of moles of methanol in 5 liters of 2 molar solution. Density of solution is 0.981 gram per centimeter cube. So if I find out what is the number of moles in 1 liter, that is molarity, I can multiply by 5 to get the answer here. So molality equal to 2, which is equal to percentage mass of solute by molecular mass of solute into 1000 by 100 minus percentage. So by substituting the values, I can get the percentage mass of the solute here. 2 is equal to percentage mass by 32 into 1000 by 100 minus percentage mass. So percentage mass of solute comes out as 6.015. Here, that's the percentage mass. So molarity is percentage mass by molecular mass into 10 into density. So 6.015 by 32 into 10 into 0.981, which is 1.843 mole per liter. Number of moles in 5 liter solution multiplied by 5. 1.843 divided 9.215 moles. Another method is finding out the mass of 2 molar solution. 2 molar solution of methanol means 2 moles of methanol plus 1 kilogram of water. So 2 into 32 plus 1000, 1064 grams. Mass of 5 liter solution using the density 0.981 into 5 liters, that is 5000 centimeter cube, 4905 grams. 1064 grams has got 2 moles of methanol. 4905 grams of solution contain how much of methanol? So 4905 into 2 by 1064, which is 9.21 moles. Then solubility product. Solubility product is the product of concentration of ions each raised to the stoichiometric coefficient in a saturated solution at 298 Kelvin. Here, the solubility product of copper sulfide is given as 6 into 10 power minus 6. Find out the molarity of CuS in aqueous solution. CuS gives you Cu2 plus S2 minus. If we take 1 mole per liter of CuS, let us say it gives you X mole per liter of Cu2 plus and X mole per liter of S2 minus. So Ksb equal to concentration of Cu2 plus and concentration of S2 minus, which is X into X square, which is equal to 6 into 10 power minus 6. So by taking square root, X equal to 2.45 into 10 power minus 3 mole per liter. That's the answer for the numerical taken. Now let's see the last one. Calculate the mass of urea required in making 2.5 kilogram of 0.25 molar solution of urea. Molar mass of urea, 60 gram per mole. So 0.25 mole, first find out what is the mass of urea in 0.25 moles of urea. So that is 60 into 0.25, 15 gram of urea. Then we find out the mass of urea solution. 15 gram is urea, 1000 gram is water, 1015 grams. So 1015 gram solution, if I want to make, I need 15 gram of urea. 2.5 kilogram, 2500 gram solution if I require, I have to make 15 into 2500 by 1015, which is equal to 36.95 grams. Thank you all for listening to this video. Next class, we'll do Henry's law, application of Henry's law and numerical based on Henry's law. Make the best use of these videos. I'll be uploading videos for all the lessons. It will help you to score well in CBSE 12 board examination. Best wishes.